Hello and welcome to this video of Power BI interview questions. This video covers 10 next question after the top 50 question which we have already released some time back. These questions are already part of the playlist. If you have watched the playlist, you have already covered all these questions. Now before I tell you the next 10 questions, let me give you a interview tip. Now some of you are asking for some time what is the better. Some of you are asking how to secure a better offer in the interview. So for that you need to do 4 things minimum. For that you need to demonstrate following 4 key aspects. Technical skill, showcase your depth of the knowledge in the subject you excel in. In this case it is Power BI. Subject affinity, display a genuine interest in the subject. Stay up to date on the latest features and know where to find the solution and how to learn new skills. How do you approach to the unknown challenges? How do you tackle the problems you are not familiar with? Do you try to relate them with the already known stuff, or do you give up easily? This matters. Communication skill. This goes beyond speaking well. It is about how you approach the interview, respond to the question, and seek clarity when you are in doubt. Above all, preparation is crucial regardless of your experience level, because some companies do not consider your resume for next 6 months. So my advice would be prepare hard. These interview questions are going to help. You can also check out the Medium blog where I have already given 101 interview questions. I will give the link in the description. So please find the next 10 questions. The next question which you may be asked, provide a measure that give the running or cumulative total using a date table. So specifically you have been asked to use a date table. Now cumulative and running total is something which is really common in the BI world. It is used in many analysis. Some of the important analysis which you can do with the help of running or cumulative total is basically finding out the on-hand inventory, finding out the balances when you have to start grouping the data from the start of the time. Now to do the cumulative, what we need to do? So let's take the case of dates when we want to do cumulative with date. So if you have a date D1, D2 and D3 and you want cumulative across these, so what should happen? The D1 will only contains D1 value, but D2 will contain D1 plus D2 and D3 will contain D1 plus D2 plus D3 and so on. This will keep on moving like this till the end of time. So this is what cumulative means. Now cumulative, it is not necessary that it will happen against date. It can happen like against the brands, categories and all other stuff, but it is very commonly used against date. Now how can we calculate cumulative total or the running total? So what we can do is basically when we have a date table, we can use calculate net. This is the current existing measure which I have. Filter all date means removing all the filters on the date, whether it is quarter, month and year, and then go ahead and say date is less than equals to the max of date. Max of date means the current date in the context, less than that. If there is nothing available in the context, it will take the last available date because of the filter context or because of the table which has been used. So for every date it is going to consider all the dates before it, and because all has been used, it means it will going to ignore any filter on the page. So this is the first version where there is any filter it will ignore. So even if you select 1 month, for that particular month it is going to consider the data which is coming in past, and that kind of case is really important for inventory, on hand and financial balances. Now the second version of this one comes with the help from all selected. In the case of all selected, we say okay, it is going to be running total or cumulative but within the selected range. In this case it will not go beyond the boundaries of the selection, and the cumulative and the running total will be calculated inside the given range. Now with the release of window function in December 2022, we have possibility to calculate cumulative using the window function also. So now using the window function, how we are going to do? We will provide parameters like position, and which kind of position? First position of which kind? First position of which type? Absolute. For this order by, go to the absolute start 1. And we are ignoring all the filters on the date. So for the dates, go till the beginning of the values. Then the second one we are starting is relative. 0, relative. Second position is 0, which is relative. Relative means still current row, the current row in the context. Till that position, the relative would be considered. All date, ignoring all the filter on the date, it means even if something is not in context, that would be considered. Order by date ascending means in the ascending order, I want to do cumulative. So this function is going to help us to get cumulative, just very similar to what we got with the all of date using the filter function. Now the next one is the same window function with all selected on the date. So instead of all, I am using all selected here. So now we have understood how you can answer this question. Let's see this in action on Power BI desktop so that you can understand how it works and we'll be able to explain this answer in much better way. So let's jump onto the Power BI desktop. I'm on the Power BI desktop now, and let me go to the Q51 page which I have already created. And to do this, I am going to bring in date from my date table. But before that, let me showcase you my model. This is the common model I am using for all my videos. So it contains the central sales table. It is joined with one-to-many relationship with the date table and other dimensions like item, customer, and geography. Today we are only interested in date table. So let me go ahead and start building the measures. So let me bring in date and create a table visual. Let's click on the date table and we will see table tool, and let me click on new measure inside the table tool. And I'm going to give this measure name as CUMM1, and I'm going to use the first measure which we discussed, calculate net. This is not going to make any difference till now. Now the difference will start with the filter function, and in the filter function we will start by ignoring all the context by using all of date table. It means everything on the date table has been removed, all the filter context and the row context, and then we say date of date means the date in the date table should get filtered using less than and equal to max of date of date. So this max of date can come from the row context. If the row context is not there, it is going to come from filter context. Even if the filter context is not there, it's going to consider the max date in the date table. So now you know how it's going to work. So we close the filter, we close the calculate. I have made it little bit large so that you can see calculate net filter all of date table means ignore all the filter on the date table. Date of date is less than equal to max. So my measure is ready. Let me press enter. And let me add this measure into the visualization. Along with this measure, let me also add net into the visualization so that we can understand this measure better. So now I have net, which is daily sales or daily net. And I also have a measure which is cumulative net. And as you can observe, each date is a sum of all the previous dates available. So if you look at the second one, it is sum of first 2. If you look at the third one, it is sum of first 3. If you look at the fourth one, it is sum of first 4, including the current one. So in this manner, I am able to get a cumulative, and this display will go till the end of time. Even though if the data is not available for some of those dates, it will still have the cumulative because it is summing up all the previous dates. So we have successfully created the cumulative. Let me copy this formula and create the second measure which we need. So I can see the measure tool because I've clicked on a measure. Let me click on the new measure from the measure tools, and let me start creating the second measure. In the second measure, cumulative 2, cum 2, or the running total 2, I am taking calculate net filter, and this time I'm going to use all selected. It means that I only want to ignore the row context, not the filter context. Date of date is less than equal to max date. Let me press enter. The measure is created. Let me bring it into the visualization. And what you will observe that this measure is giving the same result as the previous one. So you might want to ask, what's the difference? To understand the difference, we need to bring in a filter. So let me add a filter to this page. I will add month year from the date table. Let me filter on December 2019. What you will observe here is that the cumulative part is little bit higher than the cumulative 2 part. You will also observe that the cumulative 2 is sharing the same value as the first date available. This is because the cumulative 2 is starting from the very first date available because of all selected. It is considering the filter, but cumulative is not considering, is still taking all the dates which are available in the system from the beginning of the time, and because of that there is a difference. But yes, it is following the same rule of adding up all the previous date which are available. Now in this case available in the filter context. Now we are done with the calculation of cumulative using the filter and all, or all selected. Now let's turn our focus to the window function. To do that, I'll click on the new, and this time home tab is visible. From there I'll click on the new measure, and let me try to create running total 3 or cum 3. Calculate net is going to be first one, will remain same. Now let me start with window function. Now window function required from and type, which is position and the type. So what is my position? Position is 1. I'm going to start from the absolute 1 position. So based on my order by whatever is the absolute first position, I'm going to start from that. So from very first date, this means where I want to add is relative, because whatever date is available in the row context, that is where I wanted to add, or whatever date is available in my context, I want to add at that. So because of that I want to use 0, and then I would like to use relative, because this is relative position. 0 is relative, 0 minus 1 above plus 1 below, and keep on adding the numbers as you travel through the rows. So current row, then all of date. I want to ignore all the filter on the date table, and I want to consider that same as what we used in the filter. Next is order by. What order by I want? I want order by of date table. Now in this case we will leave out blanks, partition by, match by, and reset options. We don't require those. We'll keep it pretty simple. So the measure is created, and let me bring in this measure also into the visualization. Now you will observe the behavior of this measure is very similar to cumulative 1, and it is also ignoring the filter context of the month. So in this manner, behaving very similar to cumulative 1 measure. Let's create another one, and for that I'm going to copy the script of cumulative 3 measure. I'm on the measure tool, so from there I'm going to press new measure. I'm going to create my 4th measure, cumulative 4, and the only difference I'm going to make is instead of all, I'm going to use all selected. Rest of the formula is going to remain same, which I explained you a couple of minutes back. Cumulative 4 is created, and let me drag it inside the visualization. So you might have observed that this value is not in line with the value which is cumulative 2, isn't it? And I'll tell you the way to fix it is basically you go ahead and use 0 in the window instead of 1. So this works when you are working with the all, but for all selected you start the window from the 0, and the moment you do it you will see that this has started working, and it is very similar to cumulative 2. So cumulative 1 and cumulative 3 are matching, one with the window function and one with the filter all. Cumulative 2 and cumulative 4 are matching, one with the filter all selected on date and one with the window function. So in this manner, you can create all these 4 measures and utilize them. Now, what you should also explore the performance differences between these 4 measures. And I'll tell you the way, but you have to go and experiment yourself. So go to the optimize and enable the performance analyzer. I already enabled it. It will appear on the right hand side, and click on that, and then you can use start recording and refresh visuals. So use them one at a time, or you can use them on different pages and compare the performance, and do share me what kind of performance you are getting from which measure. So which one is faster, is the Windows function or the traditional manner? So having the understanding of how window function works, or how the filter all or all selected is going to work, will help you in creating cumulative. So in this manner, you can answer this question. Having a good knowledge of window function and how to use all or all selected in the filter function will help you out in solving many such problems. The next question which you may be asked is how to get top bottom performer. Now it's not about top bottom performer. You may be asked how to get second topper or second bottom performer. And we are going to address these 2 things. So to get these top or bottom performer, one of the first thing which will come to your mind is use RankX function, and then use a visual level filter, or use a filter in another measure on the rank. While you can do that, you may be asked not to use the filter pane. Then what would you do? So to address these, we have a function TOPN. Now first let's understand TOPN function, and I'll let you know the limitation when you want the second topper. The TOPN function you can use inside calculate. So TOPN gross, keep filters, TOPN, what TOPN require, number of top which you want, top 1, 2, 3, 4, all or all selected, or the column or the table. So in this case we will use a column or a set of columns, item brand, order by what, gross, and order by descending. So in this manner we will be able to use top function. So TOPN actually returns a table. That's why we are using it as a filter. Now what happens if you don't use keep filters, the top and the top 1, 2, 3, 4, if you use more, it will combine all the values and give it into all the rows. So that is why we have to use the keep filters, so that the TOPN function can work in the manner we want it along with calculate. Now for the bottom one, the only change you are going to do is you are going to change the direction of sorting. So instead of order by descending, you are going to use order by ascending. Now when you use the TOPN function and you want second topper, you can't get second topper, you can get top 2. It is top n actually. It will give that n. Top n with the 2 means it's going to give you 2 values, not 1 value. But what happens if I need the second topper? Then you will say, okay, let's go ahead and use a filter. But that's what we don't want it, isn't it? So one of the best function which we can use for that is basically the index function. And the index function was released in December 2022. Now it's not like TOPN function. It can give you a particular position. So I want, let's say, topper, I can say 1. I want second topper, I can use 2, 3, and like that. Now for top n, if you want to replicate top n, you might have to use window function, not the index function. Index function is about 1 position, which position I want. So how do you get top using the index function? So let's understand the code here. So we are going to use calculate, gross, keep filter, index, then position. What position you want? I want the first position. All selected or all item brand. Order by what? Gross, because I want topper, descending. If I want the bottom performer, if you look at the second code, you will find the very similar code. The only difference is ascending, the bottom performer. Now in this case, when you want the second topper, we have a flexibility to just use 2 and get the second topper, not the top 2. It is only the second topper. In this manner, you can take help of TOPN or index function based on the requirement to provide top performers or top performer, second top performer. Now I would like to show you these things in action on Power BI desktop so that you can understand them better. To do that, let me jump onto the Power BI desktop. And in the Power BI desktop, I have already created a new page Q52, which I'm going to use to explain this. So let me quickly bring in item brand. Now let me start creating the measures. So the first one is using the TOPN function. Let me get the top one. I have clicked on the new measure from the home tab, which was visible. Top one, calculate. And this time I'm using net measure. Keep filters, TOPN, and please watch my TOPN video where I explained how this function behaves when you simply take TOPN into the measure. When you don't take the calculate and keep filters or values, then how it behaves. All those I have explained in the TOPN function video. So TOPN, at the end value is 1. The table is all selected, item brand, all selected item brand, comma, order by expression is my measure, which is net, and the order is descending. Close TOPN, close keep filters, close calculate, press enter. Top one is ready. Let me bring in net and top one into the visualization. Net top one. So now you can see you are only seeing the top performer. Now let's quickly copy this code of top performer and bring in the bottom performer. So I clicked on a new measure from the measure tools, and let me bring in top 2, and and the only difference this time was going to be this descending will be replaced with ascending. And when we do ascending sort, we are going to get the bottom performer in this case. And let me call it as bottom 1 and bring it into the visualization. And we are getting the last value, brand 4. That's the bottom performer. Time has come that we create measures which are based on the index function. For that, let me create a new measure. From the home tab, I'm going to press new measure. And let's start with top 1 again. Calculate. And this is using the index function, so let me call top 1i. Net, keep filters, index, and what index function is required? Position. I require the first position. Relation, all selected item brand is my relation. What is the third thing which I require after relation is order by. So order by net, and this is the feature which came little bit later. It came in April 2023, where you don't need order by as part of your relation. So net order by is descending. We have to specify descending because by default it is ascending sort. And now I'm done with my index function. Keep filters and calculate. Let me bring in top 1i also along with that, and it is showing the same result as top 1. Let's also bring in the bottom one using index function. So I'm on the measure tools, and from there I'm going to click on new measure from the measure tools, paste the formula, bottom 1i. Only difference is instead of sort descending, it is now sort ascending. The measure is ready. Let me bring it into the visualization and we are getting the same result. Now let's take the case of top 2 or the second performer. We actually want the second performer, but what happens when we try it with the top function? So let me copy the code, and from the measures tool, let me press new measure and let me get top 2. Now in the TOPN function here, instead of 1, I'm going to use 2. Let me use 2, press enter, no changes in the rest of the code. Bring it into the visualization and you see I'm not getting a second topper, I'm getting top 2 because top n functions gives me top n. So this is 2 means it's going to give me 2, the 2 toppers. Now let's try the same thing with the index function, and index function will allow us to get the second topper. So I'll copy the code of top 1i from the measure tool, press the new measure, and I'll use top 2i. So what change I'm going to bring in here? I need the second topper, so I'm going to use index as 2, and rest of the things are going to remain same, no changes in the code. Press enter and let me bring in this measure also into the visualization. You will immediately observe a difference. This is talking about second topper, not top 2 performers. In this manner, index function can help you in identifying a particular position which you need as a topper or a bottom performer. So knowing the TOPN function and the index function, which is relatively new, will help you in answering questions very similar to these. It may be top n, top 5, etc., or the top performer, bottom performer, fifth performer, second performer, etc. So go ahead and try this out and do let me know if you have some questions. The next question which you may be asked is how to add a unique sequence number field in the Power BI visual. Now Power BI doesn't have a built-in property for a visualization like table or matrix where you can simply add a sequence number. So it means you have to use some kind of a measure there, and especially when you are using it to matrix visual, it would be even more difficult because rows are before it. But in a table visual, pretty much we can use on the very first column a sequence number, and to add that sequence number we would require a row number function. Now row number function, the sequence would be dependent on what you have into the visualization. So based on what you have into the visualization, you can calculate a row number, and the syntax of the function row number is you have to use the relation. So in this case I've used all selected item brand and item category, and then you need to use an order by, which I've used on net descending, because in this one I want to generate a number based on the net's descending order, and then where you want to keep the null values, that's the last option which you have to use. So let's try out this function on Power BI desktop so that you better understand how to use it. So let me jump onto the Power BI desktop and explain you how to use row number function for sequences, and we will be using a table visual. I am on the Power BI desktop now, and I've already created page Q53, which is basically the question 53 of the interview series which you're watching here. Now let me add, first of all, from the item table brand, and let's create a sequence for this. Now because I want a sequence for net and I want net to be the order of the sequence, let me bring in. So I have net in the visualization. I'll show you two sequences now, one which is based on net and one which is based on brand. Now let me create the new measure because we have to create measure for this one. So home tab is visible, and under the home tab I do have option for new measure. So I'll use that new measure first based on net. So sequence number 1, and I'm going to use directly the row number function. row number. What is the first argument? Relation, which I'm going to use all selected item brand. What is the second argument? Order by. So I'm going to use order by. And how do I want order by? I want order by of net, and that to descending. Then I can use various other argument like blanks. So blanks I want at last, so I'm going to use last. I can leave out partition by, match by, and reset because they are not applicable for this particular case. So I have generated sequence number 1, and which I'm going to place in my visualization, and I'm pulling it into the columns at the top. And as you can see, we got the sequences, and you would find this is very similar to rank function, but row number function is going to ensure the uniqueness. Now let's try the second way of this function, and this time I would like to sort based on brand, not based on the net. And I have also one challenge here. The brand is actually a text field, so what would happen when I sort out on brand? The sequencing would give me brand 1 and brand 10 together, so I don't want that. So what I'm going to do here to overcome that I'm going to include here brand ID, which is basically a numeric one for the same. And in order by, now I'm going to use item brand ID, and definitely in this case I want ascending, not descending. Again, blanks at the last. Let me bring in this sequence again near to the older sequence. And because we are now on the brand, so let me sort on this sequence. And as you can see, 1 2 3 4 5 6 7 8 9 10 11 12 13. Now this is when we have the single column. Let's try with the multi-column what happens. So let me duplicate this visual and try to add category into this visualization and check what happens. So let me add category after the brand. And what you will observe here is, let me first sort on the net, that the things doesn't seem so great. And let me sort on the category to understand that better. So if you see inside the category, you will see that it is auto partitioned. So, and this is typical Power BI behavior. Understand better, let me sort on category and then on net. Category and shift net and check the first one now. You can understand that it's getting auto partitioned. So what we need is a new sequence here, and the sequence in this case we are going to copy the sequence 1 code, and I'll create a new measure from the measure tools now, and here sequence 3. And now in this sequence I'm going to use all selected item brand and all selected item category, order by net descending, and blanks at the last. And let me add this sequence into the visualization and remove the other sequences because they are not applicable for this one. And let me sort on the sequence ascending, which is as good as net sorting descending. So in this manner you can get the row numbers into your visualization. If you are working across table, you can use summarize along with all selected on a central fact like sales and get the same kind of sequences. So try this out. Row number is a really interesting function which you can use for quite a few purposes. It is part of the series of window function which has been released over last 1.5 years. So it is good to know this function and its usage and what all places you can apply this. So go ahead and try that out. The next question which you may be asked is how to append two tables in DAX. So specifically we are talking about DAX. In DAX we have function union which can be used to append the data. So union function makes it easy to combine the two tables. When you combine the two tables, it's going to return another table, and that will contain rows from both the tables. The two tables must have same number of columns. A written table will contain the same columns as in the table 1 expression. Now union will retain duplicates. It means it is going to work like SQL union all, not like union. What is the syntax? So you can use the function union and you can give the tables which you want to append. So let's take example on Power BI desktop to understand it better. Let me jump onto the Power BI desktop. I'm here on the Power BI desktop, and to solve this question I would like to go to the table view. In the table view I have a table A which contains column 1 and column 2. One contains categorical value, another contains numeric values. I have table 2 again having two columns, column 1 and column 2, and they do have some values which are basically duplicate. So you can see A2 is exact duplicate which has been repeated here. Now let's try to append these tables. So to append these tables, I'm going to create a new table. As I have already clicked on the table, I'm able to see the table tool on the top, and from there I'm going to click on the new table. Once I click on the new table, I can give it as a name as appended table. Left hand side is the name, right hand side function union function you can give a number of tables. So I'm going to give here A, comma B. I can give more tables if I have, but right now I only have the two tables which I want to append. And as you can see, this table contains the row from the table 1 as well as table 2, and the exact duplicates are also retained. I want to make it equivalent of SQL union, which means I don't want any duplicate rows. As of now, it is equivalent of SQL union all, means the duplicate rows are retained. Let's try distinct function on this. We have a function distinct which can be used on table or a column expression. I'm applying that on it, and as you can see, it has been reduced to only 4 rows. The duplicates have been removed. So along with union, you can use the DAX function distinct to get the distinct values. Where this can be used? Sometime you will get the fact tables which have common dimensions and you have not got the dimension from the source. This is the method which can be used to create the dimension. So assume this is the table A and table B I got from the source, and I want to create a dimension table joining with both of them. The column 1, assume the name is category. I would like to create a new table. Again, I'm going to use the new table option from the table tool. From the table tools, I'm going to use the new table option, and let me give it as a name as cat. And in this case, what I'm going to do, union. First of all, I'm doing a union, and I'm going to select the distinct values from A, column A, distinct values from B, column 1. This we do to avoid the circular references. So let me show you what it gives, because it's going to give you the duplicate still in spite of using distinct, because they are internal distincts, not the distinct on the overall table. So you are getting the values, but still the distincts are not removed because distincts are only at the table level. Now I'm going to use one more distinct, and this will give you only the limited number of categories which I have. Now I can join this table, new table category, with A and B, and it will also not give you circular reference error in this case, and that's why I have used distinct at 3 places in this case. And in this manner you will be able to create a star schema on the two fact tables which had a common columns but previously not having any dimension. We created a dimension table here, and we are going to join with that, and we will be able to analyze the data together using that common dimension. So why don't you go ahead and try this out? The next question which you may be asked, give some examples of the measures we can create using the window function, or how to create rolling 12 months averages. Now rolling 12 months averages you can also create with the help of dates in period. But yes, Windows function can also help you out. A Windows function is the function which has been released in Power BI December 2022 update. After that, few enhancements has been done in this function. So this function is what can help us in quite a few operations. Now it can help us in getting rolling 12 months average, running total, MTD, QTD and YTD. Can be many other use cases where we can use window function, and as you go along and execute more and more complex scenarios, you will find window function is really useful in such scenarios. Now very recently we have got visual calculations, and visual calculations can also help in getting this. So we will go ahead and explore the window function and the various things which we can do using the window function on the Power BI desktop. I'm on the Power BI desktop and I'll go to Q55 page, question 55 page, where I'm going to showcase you how can we use window function. Let me create a visualization first of all. So I've created table visual, and in this table visual I plan to take date from the date table and net measure. Now let me quickly showcase you my model. So I have a perfect star schema model with the sales table, date table, item table, geography and customer table, and all the joins from dimension to factor, one to many, single directional. I'm going to use this. I have explained you this so that you can understand when I'm creating the time intelligence using the window function, what are the relationships which are playing a role. So I'm ready to create my first measure, and the first measure which I wanted to create is the running total, or we also call cumulative. So you can use calculate, net, and then we have to use window function. So window function, let me explain you the syntax. Window, a window function requires from, then from type. In the window function we would need this from and type. So from could be 0, 1, 2, 3, 4, could be absolute, then relative also. Then we have 2, again it could be absolute and relative. So usually 0 relative is the current position, 0 absolute or 1 absolute is the first position available for the order by, and if there is a partition by, inside that partition by and order by. We'll understand this more with the example. Relation is a table or all the elements which are there in the visual you should cover as part of relationship. Order by, in this case the order by would be date, but we can use the required order by, blanks. Then partition by, like when we are going to use MTD, QTD, YTD, we are going to use a partition by, match by and reset. For the current requirements we will not need them. So let me start creating the running total or cumulative. For that we will start for one absolute, means the first absolute position based on the window which we are going to supply, and this window can be partitioned or unpartitioned. We are right now not going to partition it. 2, 0 relative means still the current cell. Now comes the important thing, which is relation, which is going to be all selected or all. In this case I want to use all date. I can use the date table itself, or I can use date of date. I prefer to use date table. Then order by, in the order by I'm going to use date. And how do I need date of the date table, ascending or descending? Because I'm creating running total in the ascending direction, so I'm going to give it ascending. All other arguments for this particular calculation are optional. So now I have created a running total and I'm going to add it to my visualization. And as you can see, the moment I have added the running total, each and every row is getting the value which is sum of all previous row including the current one. If this is 15 plus 21, the total is 36. Same way 15 plus 21 plus 37, total is 73. In this manner it is keep on adding. Now this running total formula, if we do little bit modification, can give us MTD, QTD and YTD. I'm going to tell you that now. So let me copy this formula, and after copying this formula let me create a new measure. And I'll paste this new measure. This new measure I'll rename as MTD. So you use the same formula. Now because the date table has multiple columns, from those columns I can also use partition by. So net window 1 absolute to 0 relative, all of date table, order by date ascending, comma, leave the blanks, and then I'll use partition by. If I use partition by month, I can use month here from the date table. So what would happen? It will reset this calculation, or it will partition this calculation for every month. And when I bring in the MTD, what you will find out that there is a reset which is happening on every first. It totals up till the last date of the month, and post that you can see on the very first date the numbers are matching. And then again it keep on accumulating the numbers, and again when the next month comes in, again reset. And that is what exactly we do in MTD. Month till date means sum from first date of the month till the date available inside the context. Now the context here is coming because of the row. The context may also come in because of the filter. Now you might have understood how easy to get QTD and YTD, but let's go ahead and create those measures also. So for QTD, we will copy this MTD measure, change it to QTD, and we'll also change the column where we are partitioning to quarter year. I need a column which contain quarter and year. It makes it easy. Otherwise I need to take two columns in the partition by, one is year, another one is quarter. I bring in QTD, and it is the standard quarter which I have used in my date table. If I go down, I should see accumulation ending on the 1st of January, and the 1st of January value would be same for the net value as well as the QTD value, and it will continue to now increase as you observe till I reach 31st March. And on 1st April, you will again see a reset. So this is QTD. So now we have got MTD, QTD, and same way we can also get YTD. I'm going to remove quarter year and only give year here. If I give a financial year, it will become a financial year YTD. I should have FY column if I want to partition by FY. Let me drag YTD inside my calculation. And as you can see, now my calculations will reset on 1st January, but after the 1st January it will continue to increase till I reach another 1st January. As you can observe, this is continuously increasing, not getting reset. The net amount is increasing, and on the 1st of January there is a reset. So till 31st it will keep on increasing, and then there is a reset. So we got YTD. So now we know how to get running total, MTD and QTD and YTD, but we have not answered the question about rolling 12 months and rolling 12 months average. Let's do one thing. Let's create another page. We'll duplicate this. We'll call it question 55-1, and here in this table I'm going to remove all these things, and also I'll not bring in date. Instead of that, I'll bring in month year. Along with month year I can have net, and now here I want rolling 12. I'm going to create another measure. Now the measure which I'm going to create here for rolling 12, first I'm going to use the window function. Calculate net window. Now here I don't want absolute start, I want relative start. So -11, not -12 because current is included. So -11 relative, it's not absolute start, it's relative start. Then 0 again relative position. Now comes the relation. Now I'm going to do here is all date, month, year. The problem with the month year is it doesn't follow a sorting. Its sorting is not correct. So that is why I need to include one more date column, that is nothing but month year sort. So I included both month year and month year sort in this case because month year cannot sort properly. It does text sorting, not the month sorting. Post that I need to give order by. So relation is done, order by I need. In the order by, I can now simply give only month year sort. I don't need to give month year here. We don't need anything else right now, and I'll press enter and my measure is now ready. And now what you would observe here is it is keep on accumulating. Now because the accumulation is continuous, you would see a minor difference happening here. So usually what happens, this value and this value addition, you will find that this is not 252 up, this is only up by little amount, and this was the reason because this amount has gone out and this amount came in, and because of that you see very small increase. And here you see a large dip in spite of number getting added up. The reason this bigger number is going out and the smaller number is coming in, that is why you see a dip here, because it is just rolling 12 months. Now how do I get rolling 12 months average? Or to do average, I don't need the average for the base rows or the row level average. I actually need the average of monthly value, and to do such things we need to tell Power BI that it should sum up till a particular level and after that it should take average. And for that, so here I have to use average X function. And inside the average x function, the first thing which I need to use is values or summarize. Here I only have the one column which I need to tell that in that column you need to do a net calculation as a sum calculation, which is nothing but sum of net sales or gross sales minus the discount, which is again the sum. So I can use values. So when I have one column, I can use values. So values, date, month here sorting doesn't matter much. Till month here you do the calculation of net as it has been done, and post that you do the average. And this is the way we use the rolling 12 months average. So this is really important to understand that rolling 12-month average means monthly average, not the average coming from row level. Let me press enter and add this measure into the visualization. And as you can see, now the values are getting average out, is not just like your sum. Now how do I do this calculation alternatively in case I have been asked to do that? What I can do here is I can bring in one more measure, rolling average one, and instead of window function, this time we will have the same calculation for average x values. We can use dates in period time intelligence function. Now please remember, you must have a date table in such cases. Without date table, these calculation on your column or when you use dot date may not work as expected. So first thing is dates, which is going to come from date of date table. Date of date table means I'm giving a set of date or sequence of dates. Then start date, we use max of date of date. It means whatever the maximum date available in the context, which is nothing but end of month of, and from there I want to go 12 months back into the past, and the interval is month because I want to go 12 months in the past. And that's all the information I want to give in dates in period. I close the parenthesis. So my measure is completed, and let me bring the measure into my visualization. And once I bring this measure into the visualization, let me check is there any difference in the calculation. And as you can see, there is no difference in the calculation. Both of them is giving me the same outcome. So in this manner you can give the answer for rolling 12 months. So now you have learned how you can use window function, how you can provide average of last 12 months or rolling 12 months. So in this manner you can answer this question. The next question which you may be asked is, I'm not able to create one-to-many join in Power BI. Dimension is on the one side and the fact is on the many side. I'm not able to create and I don't know where the duplicate exists. So how do I identify there are duplicates in the table, and then how can we correct such duplicates? We will go to the Power BI file and try to understand how can we get such things. So what I've done here is, for today's stuff, in the interview file I've added one additional table which is item duplicate. And in Power Query, I have duplicated the data of the item table in item DUP table. The item duplicate table has double of item table. Every record has been duplicated. So I'll go to the model, and here I'll try to create a relationship with the sales table and try to force it as one-to-many to see what is the error I'm getting. So I'll add a new layout by pressing the plus button below. We have already done. Now here I'll bring in the item duplicate table as well as the sales table. Now here I try to create a relationship between item ID and item ID. So it's saying the relation cardinality is many to many. This should only be used if expected neither of the column or item ID contain unique value. So if not unique value, I say no, it has unique value. So I would like to force it to many to one. And it says the cardinality you select isn't valid. So I'll say, okay, let me see if single directional can work. So no, it is not allowing me. So it contains duplicates, and that is why it is not allowing me. So what is the way to correct that? So I will go ahead and show you how do we correct this. But before that, I would like to know, is there a duplicate or not? Sometime what happens, see, the challenge is I don't know what value is duplicate. Even if I want to correct it, I want to know which value is duplicate. Maybe because from the source it is coming and I don't want to control it here. Let's check can we do that. So for that, let's create a new page, call it Q56. Here in this page, I'll tell you how can you know what is duplicate. So bring in the column, which is the primary key column, which is item ID in our case, and then bring in the same column again in the visual. Now here you should use the summarization as count. If you are not allowed to do that, create a measure. Only count, not count distance. As now you can see there are column which has duplicate values, which is already visible because everything is double. Otherwise, if there are very less values, then what you can do is you can use here the count of items is greater than 1. I only want to see what is greater than 1. If there is 1 or 2 values which are duplicate, in such cases you should be able to get those values which are duplicate. Now you have identified that you have duplicate, you are unable to create a relationship. How you are going to correct it? Now to do that, if you want to correct it in the Power BI, go to transform data and transform data. Once you go here, go to the table which have the problem. So here I have my table item duplicate where I have the problem. There are two ways to delete duplicate. You can select a column, the primary key column, and delete duplicate. Or if the complete table is duplicate, you can click on this corner so that nothing is selected, and then you go here into the remove rows and then use remove duplicates. So I'm going to use remove duplicates because I have exact double which I have taken. I know now I'm not going to have duplicate, but I just wanted to tell you how I done the duplicates. So in the source, actually I've used the append table.combine, and I created the double copy of this, and now using the remove duplicate, which is table.distinct, the source, the complete table, in the first step I'm deleting the duplicates. Now use close and apply, which should remove the duplicates for you. So once it is loaded, I should not see anything in this table. There is no duplicates now. As you can see, there is nothing in this table. It means there are no duplicates. So if I create the relationship now between item ID and item ID, it's able to create that even it did not ask for what kind of relationship we want, or it did not put a pop-up. But yes, we have the properties in front of us here. If you want to modify, you can modify, or you can open the manage relationship and can edit from there, or double click and on the wire, and you can also change it. So now you know how can you identify what is the duplicate values you have in a table on a primary key, and how can you correct it. So go ahead and try out these questions and many other questions which I have already given on the blog. I will be giving the blog link here, and this is the sixth question. So you have 55 questions which I have covered as individual questions, as well as so there is a video which contains 50 questions and 10 case studies which are really important. So go ahead and check those out, and do let me know what other questions you want me to cover in this particular series. The next question which you may be asked is, what are the 4 types of relationship that can be created between tables in Power BI model? So in Power BI model means when we go ahead and do the model view and when we want to create relationship, there are 4 kind of relationship which we can create. What are those? So one is one-to-one. It's typically created between 2 tables having exact same number of rows as the other table. This type of relationship occurs when every row in one table corresponds to exactly one row in another table. So basically, let's say if I have item table, I have duplicate of item table, each item ID corresponds to another one item ID in another table, and that's the kind of scenario. Now here I have taken a duplicate example, but there could be item table and item attribute table which might have a one-to-one relationship. Now one-to-many, this is one of the most common type of relationship when one row of the table is associated with multiple row of another table. Typical this kind of relationship happen between dimension and fact. Dimension contains the values of dimension IDs like item ID or geography ID, and those keep on repeating on the fact tables which has multiple of such value. Next is many-to-one. Here the sales table is the first table having multiple values of item, and item table is the second table having only one value for each item ID. So this join is many-to-one. Then comes many-to-many. In this type of relationship occurs when multiple rows of one table associated with multiple rows of another table. So in this case, there is no uniqueness on both the sides. So item ID is repeating in the sales table and item ID is also repeating in the purchase table. So what we end up doing is creating a many-to-many relationship with item ID. There are few other cases where we do create many-to-many relationship. Ideally, we don't prefer such kind of relationship, but like when we do RLS, we do create a many-to-many kind of a relationship. Now let me jump out of the Power BI file, and I have created example to showcase you all these 4 kind of relationship. Let me go to the model view, and here in the model view, if you're watching the videos, you might have noticed that I'm using this common model, and in this particular model, I have most of the relationship which are one-to-many, dimension to fact. What happens on the dimension type, like in geography table, the city ID never have a duplicate. It's only repeated once. So one city ID is going to appear once. So city ID 1 is once, city ID 2 is only once. But in the sales table, the city ID do repeat. And that's where the relationship is one-to-many. So if you want to have a look at the data, if I go and show it to you the geography table, as you can see, the city IDs are not repeating. They are unique. And if I go to the sales table, you will see if I sort it on city ID, city IDs are repeating. So this is what it means, that in one side it is repeating and second side is non-repeating. Now what happens in one-to-one relationship? What I've done is I have this item table and I've created an item new, which is basically having also all the items ID only as one. So if I join these 2 tables, it will create a one-to-one relationship. See, it's one-to-one relationship because both the side item IDs are unique. So item IDs are not repeating. One item ID appears only once in both the tables, and that's where I have one-to-one. We have understood one-to-one, we have understood one-to-many, and many-to-one is just a reverse. So many-to-one is basically the relationship from the sales table side to the date table side. So here, if the sales is first, then it is many-to-one. If it is geography or the table which is on the one side is on the top, then it is one-to-many. So it's just a direction. Now let's look at an example of many-to-many. So let me call it as Q7. Now here, let me again add a Q5071. I'm renaming the new one. Here I'm going to bring in sales table, and I already created a item table which is having duplicate entry. Now when I join item ID of item many with the item ID of sales, what you will see is creating many to many relationship. The reason for that is that the item ID is not unique in both the tables. So let me connect it to this. So now this is going to show us a many to many relationship. Now this could be inactive because this item table might be relating with some other table. I made it active. There is no relationship issues, so I'm able to make it active. Sometime when it is not active, you just click on the relationship and make it active. Sometime if there are multiple paths or there's a loop which is getting created and going to give you an error, so those you can remove. Now I just wanted to show you item many table to you so that you are sure why it is creating many to many. So here if I sort an item, so item ID is repeating more than once in item many table, and that is why it is creating many to many relationship. Let's also have a look at the sales table, and here also the item IDs are repeating. That's why we have many to many relationship. So these are the 4 kinds of join. Usual preference from dimension to fact is 1 to many, and from fact to dimension is many to 1. But there are cases when we use 1 to 1 or many to many relationship. When we use 1 to 1 or many to many relationship, depending on the use case, we do create bridge tables to avoid many to many relationship in many cases. So go ahead and learn more about these kind of relationship. I have 2 blogs where I have these 100 questions for which I'm creating the videos now. You can read those blogs. The next question which you may be asked in a Power BI interview question, and is the question which is not related to Power BI, it is related to data modeling, and it can be asked in any data modeling or data analytics job. It may be asked if you are applying for a SQL developer job. It may be asked if you are applying for any data engineering job. It is not only a Power BI question. So the question which you may be asked is, what is SCD? So SCD is nothing but slowly changing dimension. Slowly changing dimension is a concept in the data warehousing and database management that describe how dimension or attribute in data warehouse changes over time. So basically what happens when we say update a table. So let's say the value has been changed. So what you typically do is you update that value. So that value is overwritten. But you cannot overwrite values in certain cases. You have to maintain the history. Let's say employee. Now employee has manager. They have a title. So what happens, let's say you had a title software engineer and you will move to senior software engineer. Now I would like to know in the past when you were a software engineer, how was your performance? Or how was your performance under an X manager when your managers have changed over a period of time? How do I track that back? And if I have to track that back, I need to have a record which tells me when you were software engineer, when you became senior software engineer, how your managers have changed. So any change in the attribute or the value has to be tracked along with its history. So there could be change which has been changed. You know, what was my past value? There could be possibility to track it with the start date and end date. So there are various type of SCDs which we are going to discuss how to manage these things. This is the reason why we need a history, because we want to look back how these attributes in the past, and we will analyze the data based on the value of that attribute in the past. So SCDs are particularly useful for dealing with the historical data or the data that's evolved slowly over time, such as customer information, product details, or geographical information. Employee information is just one of other information which you want to track. An important goal of managing slowly changing dimension in a data warehouse is to ensure historical accuracy and integrity. We want to maintain the historical accuracy and integrity, and that's why we do it. Means we wanted to know what happened when this customer was having these attributes, or when this product have this price, or something related to geography. Okay, so let's go ahead and look at the various type of SCDs what we have. So there are actually 5: SCD1, SCD2, SCD3, SCD4 and 6. SCD5 right now is not a definition which is agreed upon. So usually you have SCD1, 2, 3, 4 and 6, and we are only going to discuss 1, 2 and 3, and out of those SCD type 2 is one which is very common and which is also very good in tracking the history. So SCD, or slowly changing dimensions, are used to track the changes over a period of time so that you can accurately analyze your data. There are 3 main type of SCD. SCD type 1, in this type of SCD we overwrite the value. So basically we are not tracking the history. So data history is lost. So you know, my title was software engineer, I became senior software engineer. You simply updated the title, so you you don't know when I was software engineer or till what time I was software engineer. Now type 2 SCD, and this is the one which is very commonly used. This type of SCD create a new record for each change to the dimension. In this way, you can keep track of the historical values, but if the dimension change frequently, it can lead to data block. There are various ways it can be maintained. It can be maintained using versions with the mark of what is the latest version, or it can also be maintained with the start date and end date. Very common way is to use start date and end date. For what time you are holding a particular attribute in a dimension. So let's say you started as a software engineer when you joined the company 1st January 2020 and you remain till 31st December 2022, you were there, and now from 1st January 2023 you became senior software engineer, and end date might be null in some cases, so that is representing the latest record. So in this manner, you are actually creating history with each and every change of each and every attribute. Now what happens if the changes are too frequent? Like there is a dimension where these changes are too frequent, then it can lead to a lot of rows getting created. And when this dimension grows in, it may actually slows down your queries, but having a bigger dimension never works out. So if there are too many frequent changes, then we need to think about what's the best way to manage these values. And do we need to manage each and every change of each and every attribute? That is another thing you need to take care when you're creating SCD type 2. Now SCD type 3, this type SCD adds a new column to the dimension. The table stores the previous value of the change attribute. This allows you to track historical value of the dimension without data block. Now what happens is basically, because so many number of rows are increasing, you want an easier method. What is that easier method is? Easier method is just you maintain one previous value. So what happens? This value is right now X and it's become Y. The disadvantage here is you can't find out all the historical changes. Secondly, if there are more than one changes, you only know what was your last updated date when you got this one. So this might not be suitable in some of the cases, but in the places where the changes are very minimal, they happen once in a while, such things could be used because we know these things are going to change once in a while. Like, city and state relationship. If that is not going to change for a while. So these kind of things are, really slow to change. They are not going to change, every month or 2 months or a year. So in such cases, you can use additional column which tells us the previous values, and this also reduces the amount of data which we need to maintain. So this is SCD type 3. Now there are SCD type 4 and SCD type 6. You can also read about those. So let's look at some of the example how the data would look like in case of SCD. So the data would look like this, like old data and the modified data. So in type 1 we simply overwrite, we don't know the history. So item ID 1, item name is 1, brand was A, and we have modified it to the B. So this is the same record. The modified one is the same record as the previous one, but there is no tracking here. Now in the type 2, the old record again was the same. Item ID 1, name is item 1, brand is this, and the start date was this, and there is no end date initially. But later on when we modified it, the first record got an end dated and the second record started with a new start date, and there's no end date. No end date means this is the latest record. In the type 3, the old record is again same, but in the new record, the modified record, you still have the one record, you have the new value as B, the old value as A. Now this is the only theory part of it which we are covering there. Now in some cases you may be asked, and especially that happens in the SQL interviews, that you may be asked that you got the data as SCD type 1, how you're going to create it as SCD type 2. That is something really interested. If you are actually appearing for a data engineering interview, please go ahead and make sure that you prepare for that particular question. So go ahead and practice this question out. So the next question which you may be asked is, what is role-playing dimension? Now this question is more of a data engineering question, but it is really important because we come across this question many a times. The dimensions which basically have more than one role. Let's say you are using an employee. The employee could be manager as well as employee could be an employee. Now what happens? There is a transactional table, or there is a table where you have the employee ID as well as the manager ID. Both employee ID and manager ID need to be connected with the employee table to get the employee ID and manager ID. Here employee table is playing two roles of either manager or an employee. Same way we can have multiple dates. Again, those dates could be order date, shipment date, delivery date, etc. The date table has to join with all these dates to provide quarter, month, year, week information, and in this manner the date table has to play multiple roles. So let's read out the definition. The role-playing dimensions are the dimension table that are used multiple times in a model to represent different roles or perspective within the model. A role-playing dimension is commonly found in the fact table that contain multiple date related columns and attribute each corresponding to different date and time in context. This example is about date, but same case we can have with the employee dimension, where you have employee ID and manager ID, and both need to connect to employee table to get employee name and manager name. So the master or the dimension table have the same information, but its perspective will change based on where it is connected to. For example, consider a sales data model where you want to analyze sales by order date, shipment date and delivery date. In this case, it would mean that the date dimension would be used 3 times, each time with a different perspective or role: order date, shipment date and delivery date. Now, so basically what happens, if you want to join with the date dimension, which date I should join? One time it should play a role of order date, another time it play of the role of shipment date, another time it should play a role of delivery date. What does that mean? So basically when I filter the date dimension, is it going to filter the order date, it is going to filter the shipment date, or is it going to filter the delivery date? There are 3 roles it can perform. So what role it is going to perform is going to be dependent on how you are going to create that relationship. Are you going to create it with the order date, shipment date or delivery date, or is it possible to switch it at the runtime to order date, shipment date and delivery date? That is what is the role playing dimension. Dimension shifting its role from one attribute to another attribute depending on the requirement. How you can execute this? Create calculated tables. You can create the copies of dimension table and names them according to the role. You can create order date table, shipment date table and delivery date table by duplicating the date table. This can be done in Power Query using the duplicate option, or in DAX you can create another table like order date equal to date, and then you can create the relationship between the new dimension table and the fact table on the corresponding column. So now this is the one way you create the duplicate copy. You said, okay, this table is order date dimension, this table is shipment date dimension, this table is delivery date dimension, this table is sales date dimension. These kind of dimension you can create. So this is the one way. Now the second way is you use relationship. So what happens in this case is you can keep the inactive relationship in your model. This is something which is specific to Power BI. In Power BI, what happens is if I created, let's say, a relationship with order date or ship date, then when I create the second relationship with the date column or any second relationship I will create, that will become inactive relationship. So what would happen? One relationship between the date and the ship date, one relationship between date and the delivery date. Now one of the relationship inactive, and whatever I want to use that inactive relationship, I can use relationship function and can specify which join I want to activate. Now for the active relationship, it is not important to mention the use relationship. It is continue to use, but if both are inactive, there are scenarios. If you watch my HR analytics video or HR analytics file which I typically share on the community, in one of the case we do use when both the joins are inactive with the hire date as well as the termination date, and that's a very common case when you hire and terminate. So hire date, termination date, one of them can have active join or both of them can have inactive join. Those are the kind of scenarios you can have. So use relationship function is one which helps you in activating that relationship. So you can keep the inactive relationship in your model and create a measure that use relationship function to activate the desired relationship in the calculation context. For this you need to create multiple relationship with one common table. So here there is only one table, but you are creating relationship, and based on the measure it's going to change the relationship. This is one very good example here. Calculate sum of sales, gross sales, use relationship, sales date and the date. And the second example is by delivery date, where we are using the same sum of gross sales, but we are using the delivery date along with the date of date. So basically activating this particular relationship. Now for the active relationship, use relationship is an optional, but if you expect that these could be changed, the active could be changed to inactive, inactive could be changed to active in the future, you can always use relationship to be on the safe side. For an active relationship, use relationship is not needed. What we are going to do is we are going to see this in action on the sales table, but my advice would be please go ahead and watch the 2 videos on HR analytics. There are a couple of videos where we have done this, active employees kind of a stuff. You should watch that. That is really good use case of this, use relationship or role playing dimension. So I'm going to go to my Power BI file, which I'm using for the interviews, and so I opened my Power BI file, and in this file I'm going to jump onto my model, and in the model I'll create a new layout, and let me call this Q59 because this is for question 59 of the interview question. And here let me drag sales table, and let me also drag the date table. And as you can see right now here, there is only one relationship between the sales and the date table, and that is the active relationship between the date and the sales date. But I also have a delivery date here. I want to create this relationship. So I'll drag the date of the date table on the delivery table, and this is from the date of date to the sales delivery date, and this is one to many because the date table is on the one type and the single direction. You can't make it active because the moment you want to make it active, it says there is already an active relationship existing, so you can create an inactive relationship. Remember, if inactive is also creating some kind of a loop, it may also give a warning because it's creating double path or it is creating loop, so it may throw an error in such cases. This is an active relationship, so it can work without use relationship. This is an inactive relationship. For inactive relationship, you have to use relationship. So let's go ahead and create a visual and try this out. So again, we are going to add a page. We are going to call it Q59 because this is for question 59. And here what we are going to do, we are going to bring in the date from the date table, or we can even bring in date. So we got the date here. Along with the date, we can bring in net. So net is a measure which is created without use relationship. And let me convert it back to the table. And I uncheck the arrange data for me, so it should remain table now. Now let's do one thing. Let's use this net and create the two measures with the use relationship, and let's see how does it make any difference for us or not. So net sales date, which is already in active join, should not make any difference. Calculate net, I'm using already existing measure which is just doing a sum. So calculate net comma use relationship. What are the argument use relationship needs? It needs the column 1 and the column 2. Two argument it needs for the relationship. So what are those two columns? Sales date is the first argument and the date of date is the second argument which I need. So let me create this measure and I bring this here, and you will not see any difference in any of the dates here. Let's sort it on the date to understand it better, and as you can see, there is no difference in the data here. Now let's do the second stuff, and the second is I'm going to copy this formula net sales date, create a new measure from the measure tool, and add here net use relationship. Instead of sales date, I'm now going to use delivery date. And I will also rename it as net delivery date. Let me press enter. The new measure has been created, and let me add it here. And the moment I add it here, you can see there is a difference. And the moment I do this, you will see there is a difference in the values of both the measure. And the reason for the difference is one of the measure is running on sales date, another one is running on delivery date. And my sales date and delivery date are not same. Usually most of them are more than 1 day delivery. So this is where same date table or same date dimension has been used, but it is playing different role. One time it is sales date dimension, another time it is delivery date dimension. How my data is looked by delivery date, and in the first two cases it is how it is looking by the sales date. So when you don't have the inactive relationship, you don't need to use relationship. That's what it means. So in this manner you can use it, and there are many use cases which you will be able to draw. It is not only the date table, there are many other dimensions which will be behaving like role-playing dimensions. So you should be remembering this important feature, role-playing dimension, and how to use it. Do practice the HR file which I have shared with you, and HR videos which I have shared with you before you are preparing for your interviews. Hope this will help you to answer this particular question. The next question which you may be asked is, what is conformed dimension? Now again, this is a data warehousing or data engineering question more than a Power BI question. Power BI is part of the data engineering where Power BI plays a role to interact with the end user. You can do end-to-end data engineering on Power BI, but in some other cases we might need the help from the data warehouses, lake houses, etc. While doing a Power BI interview, it is essential for you to revise some of the data warehousing concept, and those data warehousing concept include facts and dimension and type of facts and dimension and how they can be created. Because of that, we are covering these questions, and one of these questions is, what is conformed dimension? Conformed dimension are those that have the same meaning and the content when referred to from different fact tables. In other words, this means that a dimension can be used to analyze the data from multiple perspectives at the same time with the no need to worry about its consistency and consequences. So basically the meaning remains same. Its meaning cannot change when I use it with different fact tables. In data warehousing and business intelligence, conformed dimensions play an important role. For example, if you have a date dimension table that is used by sales, purchase, finance, employee, inventory and budget tables, you want to make sure that the date dimension has the same structure, attribute, definition and domain value for each fact. Using the same date dimension, you will be able to analyze and compare the data from different fact tables in an easy way. Usually date and time dimensions are conformed dimension. Their attribute meaning do not change. A month here is going to remain month here even if I join with the sales, purchase or finance or employee. So this is what we call as conformed dimension. So you should be knowing about few types of dimension, and this is one of them. So please remember this definition. Thank you for taking time to watch this video. Your curiosity and quest for the knowledge are what's inspiring this series. If you have any question or topic you would like me to explore in this series, please let me know in the comments below. Your support is truly means the world to us. It's the reason we create and share these videos. If you have enjoyed this content and would like to see more, please consider liking, sharing and commenting. It helps us immensely. Until next time, keep learning and stay connected. Thank you.